All right, so here is a quick review of the product and quotient rules. So the product is used whenever you're trying to find the derivative of two functions of x that are being multiplied together. So you have your function f of x, and let's think of that as the first function, and you have that multiplied times g of x, which is going to be our second function. And let me use a different color for g of x. Let's go red. So to find the derivative of this, the formula is that you take the derivative of the first function and multiply it with the second function, and you don't do anything to the second function, so it's just times g of x. And then you add it with the opposite of what you just wrote. So you would multiply that times the first function unchanged times the derivative of the second function. And because of the commutative property of addition, you could actually write this the other way. You could write this as the first function times the derivative of the second plus the derivative of the first times the second. So either way works. Just notice that you're taking the derivative of one function and then multiplying that with the other function unchanged. And then you're just adding, doing the same thing, but reversing or doing the opposite for the functions. So another way to think about it is that if you're taking the derivative of the first function, so you could think that, well, f prime was my function 1 in blue. So f prime is my d1. And then I'm multiplying that with my second function unchanged. That's just times function 2. And then I'm adding that. And then on the other side of that addition sign, I've got f of x, which is my first function unchanged. And I'm multiplying that with g prime, which is the derivative of my second function. So it'd be d1 times 2 plus 1 times d2. And the 1 and the 2 there, those are the first function, second function. So let's see how that works with an example here. So this is from worksheet 2 on derivative rules. This is the worksheet that's posted to the Google Classroom. So if we go to the Google Classroom for today, then it's just under attachments right here, worksheet 2 on derivative rules.pdf. So here is number 1. We've got y is equal to x squared minus 4x minus 6. So I'm going to think of that as my f of x. And so that's my first function. And then that's being multiplied with x cubed minus 5x squared minus 3x. So I'm going to think of that as my g of x, otherwise my second function. So I'm multiplying two functions of x together, and I want to find the derivative of these guys. So the derivative of y would be y prime. And then I want to follow the product rule. So the product rule says I'm going to do the derivative of the first times the second plus the first times the derivative of the second. So one at a time, I just need to go through this formula and work out what each of these pieces are. So the first piece here is f prime of x. If this is my f of x, then I need to figure out, well, what's the derivative of just that first parentheses. And so this, I'd be using some of the different derivative rules we learned, as well as the power rule. So to do this, I would be using some of the different derivative properties that we've learned, as well as using the power rule. So then the derivative of, so then let's take it term by term. The derivative of this x squared. So let's take it term by term inside of this first parentheses. The derivative of the x squared, well, that's using the power rule. So the derivative of x squared is 2x. And then I have a minus sign. And then the derivative of 4x, well, 4 is a coefficient. So if you have a coefficient in front of your x, you can just kind of just copy and paste that. And then the derivative of that x right there is 1. And then I have a minus sign, and then the derivative of the 6. Since 6 is a constant, there is no variable next to it. Derivative of constant is 0. So that's my f prime. So I've done this part. So now I have to take the now I have to rewrite g of x. So notice g of x is just g of x by itself. I don't have to take the derivative at this point. So I'm just going to draw parentheses and then copy and paste the g of x. X cubed minus 5x squared minus 3x. So then the product rule says I now have to add. So I add between these. And then I'm going to do f of x times g prime of x. So f of x, I just have to copy and paste f of x. So f of x was x squared minus 4x minus 6. So that's f of x done. And then g prime of x, so I'm taking the derivative of the g function, which is this right here. So term by term, I'm going to look at, well, what's the derivative of x cubed? That'd be 3x squared. And then what's the derivative of negative 5x squared? So I have my negative. 5 is a coefficient, so I can just copy that down. And then I can use the power rule on x squared. So if I drop the exponent out front, that's a 2 times x. And then subtract 1 from the exponent, so that's to the first power. And then finally we have minus 3x, so negative 3, that's your coefficient. And then the derivative of x is a 1. So that becomes this long mess. So remember, if you're doing a free response question, you could actually just leave your answer like it is right now. So once you've done the calculus, you're technically done with the problem. If this were a multiple choice question, we might need to clean this up a little bit. So let's see what we can do to clean it up. Well, this first parentheses, I have a 2x, and then negative 4 times 1 is negative 4. And then if I'm subtracting 0, I don't have to write that. The second parentheses, I didn't actually do anything to it, so I can't simplify that next parentheses, so I'm just rewriting it. Same thing with the third parentheses. I can't simplify that. And then the fourth parentheses, we have 3x squared. Negative 5 times 2 would be negative 10 with an x. And then negative 3 times 1 is negative 3. So let's look at each parentheses and see if any of these are the same. So I have 2x minus 4. I don't see any other parentheses of 2x minus 4. I've got an x cubed minus 5x squared minus 3x. I don't see any other parentheses with that. It's okay, so all 4 of these parentheses are actually different. I'm not going to actually multiply all this out. That would be a huge mess, and it's completely unnecessary. So I'm just going to put a box around this and call this done. So you might notice, going back to the original problem, that you could have actually multiplied all of this out. So you could have multiplied everything in this first parentheses with everything in the second parentheses, and then you could simplify that, and that would have given you an equation for y that you could have found the derivative without having to actually use the product rule. So sometimes there is a way around the product rule. However, multiplying all this out would take you a lot longer than what we just did here for the product rule. All right, so number two. We would have to use the quotient rule. So let's go up here and talk about the quotient rule. So you would use the quotient rule whenever you have a function of x divided by a function of x. And so I'm gonna explain the way I remember this first, and then I'll show you how you can build the formula from that. So I remember this by this phrase, low d high minus high d low. I guess low has a W on it. So low d high minus high d low over low squared. Low d high minus high d low over low squared. Sounds like a song from a Disney movie. All right, so low in this case is your bottom function. And then high, of course, is the top function. And I just realized, so high is actually spelled H-I-G-H. Whatever, you understand what I'm saying. Let's just be lazy and write it as H-I. So I want to create an equation based upon this phrase. So low would be the bottom function, so that's g of x. D high is the derivative of the top function. The top function is f of x, so the derivative of f of x is f prime of x. And then I have a minus sign. High is the top function, so that's f of x. D low would be the derivative of the bottom function, so that's g prime of x. And then I have a comma, so then I have over low squared. So all of this that I've written gets divided by low squared, which would be g of x, and then that is squared. So low d high minus high d low over low squared. So let's go down here and figure out the derivative for number 2. I'm going to have to write this above it. So I've got my high function is on top, low function is on the bottom. So the derivative of this, y prime, would be low d high. So low is the bottom function, 2x plus 3. D high is the derivative of the top. So the derivative of 3x minus 2 is just a 3. Minus high, which is 3x minus 2. D low is the derivative of the bottom, so that's 2. All over low squared. So the low is 2x plus 3. Put a parentheses around it and then square it. And then, so if this were a free response question, you could be finished right there. Just put a box around it. If it's multiple choice, we need to simplify a bit. So let's distribute the 3 into this over here. So 3 times 2x would be 6x. 3 times 3 is a plus 9. And then distribute this 2 into these guys. So I have a minus sign, parentheses. 2 times 3x would be 6x. 2 times negative 2 is negative 4. And I'm going to leave the bottom factored for now. So now we can, if we distribute this negative into this parentheses, we can pretty much just drop the parentheses and then change the signs of both these terms. So this 6x would become a negative 6x, so it would just take on that negative out front of it. And then this negative in front of the 4 will become positive. So now we have a 6x minus a 6x, so those are going to cancel. And then we have a 9 plus 4 that we can combine. 9 plus 4 is 13 over 2x plus 3 squared. And that is fully simplified. So for number 2, let's check our work. So the answers are all the way at the bottom of this. So 2, we got 13 over 2x plus 3 squared. 2 is 13 over 2x plus 3 squared, so we got that right. And then for number 1, it looks like they left this factored like we did. So they just left it, they simplified within the parentheses and then left it like that. So that would have been your multiple choice answer right here. So let's do 2 more. So this, let's see, let's find a good one. So find the equation of the tangent line to the graph of f at the indicated point. Use a calculator to confirm your results. So I need to find the equation of a tangent line. So remember, anytime that you're looking for the equation of a tangent line, start with the point slope formula. And the point slope formula is y minus y1 equals m parentheses x minus x1. And if we turn this into calculus terms for the tangent line, this would become y minus f of a equals f prime of a x minus a. So in this case, we're given this point xy. Well, the x coordinate, that's our x1, which is the same thing as our a. And then the y coordinate is our f of a. So inside of this formula here, I'm going to copy it down one more time. So we have y minus f of a equals f prime of a x minus a. And so this f of a, this needs to be something that we replace. F prime of a needs to be something that we replace. And the a is something we replace. So if we can replace those 3 things, then we will be done with this answer. We'll be done with this solution. So let's go ahead and replace what we know. F of a is given to us as this coordinate right here, -9. So we would have f minus, and then f of a is -9. Equals f prime of a, so I don't know what that is yet, so I'm going to leave that blank for now. And then we have x minus a, and a was given to us as that x value, so that's -1. So the only thing that we're missing is the f prime of a. So to find f prime of a, well, first I need to figure out what's f prime of x. So to do that, I'm going to go back to my function, x minus 2, and then that parentheses is multiplied with x squared minus 3x minus 1. And I'm going to use the product rule to find that derivative. So product rule says that I take the derivative of the first parentheses. First parentheses is x minus 2, so the derivative of that is 1. And I multiply it with the second parentheses unchanged, so that's x squared minus 3x minus 1. And then I add that, and then I just copy and paste the first parentheses, so that's x minus 2. And then I multiply that with the derivative of the second parentheses, which would be 2x minus 3. And the only thing I can really simplify there is just notice that we have a 1 here being multiplied with that second parentheses, so that 1's not going to do anything. So I'm just going to cross that out. And so ultimately we're looking for f prime of a, where a is equal to -1. Well, we have our f prime of x here. excuse me, I wrote this as y. This is actually y prime that we found. So y prime is actually our f prime of x. So those two things mean the same thing. F prime of x is y prime. So if I want to know f prime at our point -1, then I just need to plug in -1 into our y prime formula. So this starts off with x squared, so I'd have -1 squared minus 3 times -1 minus 1. And then x minus 2 will be -1 minus 2. And then 2 times -1 minus 3. And things are getting a little tight here. Let's move these over. So then if we clean this up, -1 squared would be +1. -3 times -1 is +3. And then it's -1 at the end. And then after the plus sign, we have a -1 minus 2, so that's -3. And then the second parentheses is 2 times -1, which is -2, and then minus 3. So the first parentheses, the 1 and the -1 are going to cancel each other out, and we're just left with a 3, and we don't need the parentheses around that anymore. And then over on the right side of that plus sign, inside of the second parentheses, it's -2 times -3, sorry, -2 minus 3, which is -5, and then -5 is being multiplied with -3, so that's a +15. So then it would be 3 plus 15, which is 18. And that's our f prime of -1. So 18 can go in here. And then just put a box around it because we're done. If you wanted to, I mean, you could at least combine the signs here. Y minus a -9 would be y plus 9. 18x plus 1. But really, if it's a free response question, that's completely unnecessary. If it's a multiple choice, then this is probably what you're going to see for the multiple choice answer. So that was number 13. So let's look to see if we got that right. 13. So 13 actually has it solved for y. So let's do that and make sure that we have the same answer. So if I want to solve this for y, then I need to subtract 9 on both sides. And also I need to distribute the 18. So then the y is going to be by itself. 18 times x is 18x. 18 times 1 is a plus 18. Then I have a minus 9 at the end. So then I get 18x plus 9. So that's the simplified answer solved for y, 18x minus 9, 18x plus 9, and that is the correct answer.